is the process in which things go up and down in that up, up, down, down kind of motion, right? So sinusoidal really means graphs that look like sine and cos, right? Up, up, down, down, up, down, down, up, down, down, up. It does that same thing all over again. Now, we looked yesterday at y equals a sine b theta. But now, we're going to add c and d, or as you guys like to call them, I don't know why you guys call them, but you call them h's and k's, right? Is that what you call them? Okay, so an h is a shift on the x direction, and a k is a shift in the y direction. So we went through the amplitude when it's out in front. Y equals a sine theta. If a is positive, you're stretching it positively. So if your a was 3, instead of starting at 1, you're going to start at 3 and then go down 3, up 3, if it's cos, right? If it's sine, you'd start at 0 and go up 3, then down 3, then down 3. Now, if your amplitude was a negative value, like if your a value was -5, for cos, instead of starting at 1, you're going to start at -5, then go up 5, up 5. If it was sine with a -5, you're going to start at 0, but then instead of going up to 1, you're going to go down 5, and then up 5, up 5. Okay? Now, the b value we kind of had figured out that you have to take the period length 360 or the period length 2 pi and divide it by b. Okay? Either way works. If you're doing 360s or if you're doing 2 pi's, the biggest thing is take a look at what the question's asking. If it wants it in radians, keep it in radians. Or if it says through -2 pi to +2 pi, you know they're asking for it in radians. If it says from 0 degrees to 180 degrees, they're asking it for it in degrees. Okay? So we did A's and B's. I don't know what you're talking about. Sorry, that's creepy, right? Don't put that on the ODR for me. Okay. Inappropriate storage. Okay, so the big thing about today is to look at C's and D's, or in your guys' cases, they're called H's and K's, right? So this would be an H. Horizontal translation is also called a phase shift, and lots of times they call horizontal translations phase shifts. Okay, so the phase shift is moving the x values. So instead of starting at 0, 0 for sine, maybe it shifts pi over, right? So then we'll have to actually start sine at pi and then go up 1, down 1, down 1, up 1, okay? There's also a vertical displacement. That's your k's. And it's just called a vertical translation. It's just shifting up and down, okay? So if there was a +1, we'd move the graph 1 up. So it would go 2, 1, 0, 1, 0, 2. It would just continue to, or 1, 2, 1, 0, 1, 2, 1, 0, instead of going 1, 0, -1, 0, 1. So it's just bouncing 1 higher. I think it's easier to actually look at examples of this. So let's look at an example of this. But before we do, realistically, you've got to think about your horizontal stretches, because that'll change your period length. Then you think about your vertical stretches, and then you'll do your translations. Okay? So what do? Well, I figure out my period length, and then I write my new scale. Okay? But sometimes writing my new scale will depend on what shift I'm doing. Hi. Sure. Did you want to pick up some ODRs? This is a perfect timing.
It's happening right now.
Okay, so let's take a look at some of these examples. Now, before we really get into some of these, I want to do just a change here. I want you to do shifts by pi halves, just so we can do an easy one first, so you can see an easy one before we get into some crazy detail. Okay? So my A value is 1. My B value is 1. So my period length is 2 pi, right? But what's my phase shift? Theta minus pi halves. Positive pi halves, because remember when we take that h out, it changes the sign. What's my vertical displacement? -1, so I'm shifting everything down 1, okay? So when I do this, I actually even write my A, and I write my B is 1, so then my period length is 2 pi, okay? So when I go to graph this, I create my little axes. It doesn't tell me how long I need to do this. Yeah? The period length is always 2 pi unless you have to divide by a B value, okay? For sine and cos. So period length is 2 pi. Lots of times I find these really, really small to draw, so instead of going up 4 and writing 2 pi, I go up 8 and write 2 pi, or I go up 12. It depends on what else I need to break into. But I'm going to go up by 8 and write 2 pi. So half of 8 is 4, and half of 2 pi is pi. Half of 4 is 2, and half of pi is pi halves. So it's 1 pi half, 2 pi halves or pi, 3 pi halves, 4 pi halves. So then this next one is 5 pi halves, then 6 pi halves, which is 3 pi, 7 pi halves. Okay, it didn't tell me how many period lengths I needed to do, so I'm going to stop there. Okay? Did it say anything about from 0 to 2 pi or, okay? If it does, you should follow that regulation. Now, then I think about this. What was the original question? The original question was cos. Where does cos normally start? Cos normally starts at 1. So I guess we should label 1, right? So I'm going to label 1 here, 2 here, 3 here. This is -1. This is -2. So determine the phase shift and vertical placement. Okay, so y equals cos theta negative pi halves minus 1. So cos normally starts at 1, right here, right? But we're going to shift it. What are we shifting it? Over a positive pi halves and down 1. So I'm actually going to start right here. What's my amplitude? 1. So cos starts here, goes down, down, up, up. Okay, but we shifted it over and down, but we didn't change anything about cos. So cos now will go down, down, up, up, down, down. So it looks like, oh, there's a triangle if I have never seen one. Okay? So we shifted it pi halves over and down 1. Because I tell you, if I would have actually taken this and shifted it, come on, work with me, shift it over pi halves and up 1, that looks like a normal cos graph, right? But that graph was shifted down 1, come on, work with me, and over a pi halves. Okay? So if you shift it down and over your starting point, and then you just follow the cos rule, down, down, up, down, down, up, you only have to move 1 point, the starting point. Okay? Is this good? Okay, let's take a look at this next one. No. Yeah. Okay, what's the phase shift on this thing? Pi quarters. Negative pi quarters, because when we take it out of the brackets. Now, vertical displacement, 2. So we're starting 2 higher than the original sign. So if sign starts at 0, we're going to start at 2, and then go up 1, down 1, down 1. So we're going to go 2, 3, 2, 1, 2, 3, 2, 1, instead of 1, 0, negative 1, 0, 1. Okay? What's the A in this case? 1, because it's the value in front of sign, and B is 1, so that makes my period length 2 pi. Okay? And this is where you've got to think about, what am I shifting? So 2 pi, the quarter of 2 pi is pi halves, right? A quarter of, so it's pi halves, because if I take that and I divide it by 4, it gives me pi halves. But I've got to shift it pi quarters, which is half of a pi half. So when I make my scale, I want to make it wide enough that I can include the pi quarters, which is kind of what I did up here anyway, just because it was nicer to see. Because I have pi quarters, it's every other one in between, right? So if I go to draw this through the middle and down, 1, 2, 3, 4. This is 2 pi, right? This is pi halves, and this is 3 pi halves. Could you go up by pi quarters because you know you're shifting by pi quarters? Yes. So then it would be pi quarters, pi halves, 3 pi quarters. It's just hard to fit that all in, right? So some people, knowing that we're shifting a pi quarters, will write the pi quarters in instead of the pi halves. So 1 pi quarter, 2 pi quarters, then they write 3 pi quarters, 4 pi quarters, 5 pi quarters, 6, 7 pi quarters, 8, 9 pi quarters, 10 pi quarters, 11 pi quarters, 12, 13 pi quarters. So instead of writing the pi halves, they just write the pi quarters in there. They skip every other quarter, right? And this right here, that's negative pi quarters. And that's negative 3 pi quarters and negative 5 pi quarters. Okay? So you just have to realize, okay, I'm shifting by a pi quarter, so instead of the pi halves, I probably want to know the ones that are stuck in between those pi half movements, the pi quarters and the 3 pi quarters, right? Now, what else are we shifting? We're shifting a displacement of 2. So we kind of have to have 1, 2, 3, 4. Hopefully you're better at hitting the line than I am, okay? Where do we start? We are with sine. So sine normally starts at 0, 0, but we're shifting back a pi quarters and up 2. So back a pi quarters and up 2, I'm starting here. But then we have to remember every 2 blocks is a quarter in the period length, because we drew every 2 blocks a quarter. or like pi half, right? Because pi half is a quarter of the period length. So at sine, normally you start at 0, then you go up 1, down 1, down 1, up 1, right? So we're going to go up 1. So we'll go up to 3, then down 1, then down 1.
So you go to the negative pi quarters to positive?
Pi quarters, because a quarter of a period length is pi halves. And we just keep on drawing it. It really depends on how long it says to go to. If I look here, there's 1 period length. Oh, I'd have to go 1 more to get 2 period lengths. There's 2 period lengths, right? At 15 pi quarters. You want to try and make them rounded. I'm really bad triangular shapes today. Okay? So, sometimes they shift pi thirds. What can I tell you? Try and guess where the pi third is, and then you can move 2 blocks every pi third. Okay? But then you have to realize it's pi third plus pi quarter, or pi third plus pi half, whatever that quarter of a period length is, right? And so if you have to come up with those numbers, you might have to do some fraction adding.
So like, we have pi quarter as an h. If we, or even like say, the next example would be pi thirds. Can we just start at pi thirds and go up by pi thirds?
You can't go up by pi thirds. It depends on what your period length is divided by 4. Your period length divided by 4 is what you go up by each time. Okay? So let's see if we got one of those weird shifty things. This one's a degree one. Should we do, let's do 1 degree one, and maybe we'll go back and deal with the pi third shifting guy. Okay? So what's the amplitude of this guy? -5. What's the period length? Well, we got to look at what B is. B is, and so period length, because we're dealing with degrees, is 360 divided by 1/2, which is 720. So our period length is 720 degrees. What are we shifting? A positive 90 degrees. The vertical displacement is 15 up, and the domain in the range. Ooh. Okay, so we moved 15. Sine normally starts at 0, but we move 15, and then we're going down 5, so that'll be 10, up 5, so that'll be 20. So between 15, we're going down 5 and up 5. Oh, that'll be your range, right? So our range is going to be between 10 and 20. Y is an element of the reals. But what's our domain? They'll continue on forever unless they tell you a certain domain they want to stop by, right? So we can say our domain is just x such that x is an element of the reals. If we were going to draw this, and I'm going to draw this on the side here, our period length is 720. So I have to find the quarters. If I go 720 divided by 4, that's 180. Do you guys agree? So each quarter of a period length is 180. And when we look at that, if we did that, that would be 720, 360, 180, 540. Okay? But we're shifting 90. So what are the important ones for us? 90s, 270, 450, 630, and 810. Those are the good numbers that we need, because those are the numbers we're going to land on. So another trick of mine is if we're shifting and it doesn't match up with the line that I already have going underneath, I start writing the line on the top, so then I know that I have to hop from here to here to here to here to here, and then I ignore all those bottom crappy things. Okay, so I still get the nice space out, but it doesn't get all confusing like it had gone in the past where we had stuck them all in between. We also need shifts, and we also need to go all the way up to 15 and 20 and 10. This is where my imagination comes in. Sine normally starts at 0. It's shifted 15 and 90, so sine's going to start here. My amplitude is a -5, so does it mean I'm going to go up to 20, or does it mean I'm going to go down to 10? So we're going to go down to 10, then up to 15, then up to 20, and then back down to 15. It's not as nice as a looking kind of one. If I had lines, it would be nicer, right? But that's one period length. Down, up, down. And we could go back, because this could be -90. And at -90, you could be at 20, right? So it should go. If I actually hit the right points. Okay? So we wanted to go back here and look at what a pi-third one might look like. You guys just want to watch? Do you want to write it down somewhere? It doesn't bother me. I'm going to just try and run through it quickly, but efficiently so you understand what's going on. Okay? So phase shift is pi-thirds. Vertical displacement of -1. The amplitude is still 1, and my period length, because my b is 1, my period length is 2 pi. So right away, I might look at, and lots of times this is what I do, I start and I go 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? That gives me 2 pi. That gives me pi. That gives me pi halves. And this will give me 3 pi halves. Now, I'm shifting a pi-third, right? If I'm shifting a pi-third, where does pi-third fall in? Somewhere in between 0 and pi halves. Do I really need to know exactly where it is? Well, if I'm really anal retentive, maybe. But really, pi-thirds fall in somewhere around there. And then everywhere I'm shifting is another pi-quarters. So how do I actually, or not pi-quarters, pi-halves, right? Because each one of these lines is a pi-half. How do I figure out what that next number is? I go 1/3, or pi-thirds, plus pi-halves. How do we deal with fractions? Common denominator. So what is really my, it's 2 pi 6 plus 3 pi 6, right? That gives me 5 pi 6. And then if I add another 3 pi 6, this gives me 8 pi 6, which is 4 pi-thirds. And then if I do 8 pi 6 plus 3, that'll give me 11 pi 6. Okay, so do you see how you can come up with that number for that thing, for the scale across the bottom? Now, sine normally starts, is this sine or is this cos? Cos. Cos normally starts at 1. But we're shifting it. So let's say this is 1, this is 2. Oh, that's a really good line. This is -1. This is -2. So cos normally starts at 1, but we have a vertical displacement of -1 and a phase shift of pi-thirds. So cos normally starts here, but we're shifting down and over, so cos will start right here. But cos then goes down, down, up, up. right? What's the amplitude of cos? 1. So down, down, up. And if I had another one, it would be right here, up. Right? And so that would be 14 pi sixths or 7 pi thirds. And so I would graph it like that. Would my next one fall right here? Well, right here? No, it would fall back that amount, right? It would fall back here. Well, not right at 1 though. Okay, but do you guys see how it would work? You just got to keep on moving a pi half over from that pi third. All right. What other questions do I have for you? Oh, a few. Write the equation that has an amplitude of 2, a period of pi, a phase shift of pi third to the left, and a vertical displacement of down 1. Well, we can start plugging in. Amplitude of 2 is just 2. Sine, I'm going to leave a space for the b. We want a phase shift to positive pi thirds, so how does that belong? Minus pi thirds. Oh, to the left. If we're shifting to the left, we want negative pi thirds. So we need a positive pi thirds there. And then a vertical displacement of 1 unit down. What's your question?
In our unit before this,
Yeah?
do we have to go like 1 over b or whatever?
Yeah?
When do we have to do that?
That's when you're doing like 2 pi over b. Because the period length is what 2 pi is, which is replacing your 1 of the old stuff. Okay, so in sinusoidal graphs, that 1 becomes 2 pi, or 360 degrees. So, how can we make a period of pi? Well, we know 2 pi divided by b is equal to your period length, or your period. How can we make 2 pi over b equal pi? We divide by 2, right? 2 pi divided by 2 would just give me pi. And that's what we want. So I would pick that. Some people have trouble with that, so they make this over 1. And when you cross multiply, you get 2 pi is equal to b pi. And then you can divide by pi to get b equals 2. Okay? That's just another way of solving. Especially if it's harder math. Like this one's an easy one, but if it's a harder math kind of question, I change it into a line equals line and a heartbeat. Okay? Now, I think you guys have the basics of this. It's just you need time to practice. Because this is just graphing it again. And we went through another graph instead of this one. But can you also look at graphs and kind of figure out what's going on? So let's take a look at this graph. Then if you can look at graphs and tell what's going on, this is example 5. Okay, this goes up to positive 5 here and down to negative 1 here. So I can look right here and say that the whole graph covers 6. So what's my amplitude? 3, half of 6, right? Because that means half of it, right? So this is a displacement of 6 from top to bottom. So my amplitude is going to be 3. Now, if we're going to deal with sine, sine's period length, cos's period length is the same thing. It is 2 pi. So if we take a look, this is starting at negative 1. So at the very bottom, if we go up and back down, it's really hard to tell what this number is. You guys know, can you guys read that number? 2.09. Okay? So that's one period. One period length is equal to 2.09. Well, we know 2 pi divided by b is equal to your period length, in this case of 2.09. If we put it over 1 and cross multiply, we end up with b, or 2.09b, is equal to 2 pi. So if we divide by 2.09, I don't know what 2 pi divided by 2.09 is. I'd go 2 times pi, n bracket, divided by 2.09. What do we get? 3.01. So that's what the b value should be. So we have an a and we have a b value. Then we just have to kind of decide, okay, what's going on? Now, this really looks like it's starting at the very bottom right now. So I would say my amplitude is almost a -3 in this case. But it really depends on what you think's going on. Is it a sine or is it a cos? When you see this, what would you think it is? Some people, and a lot of people, will think it's cos because it's starting at the very bottom, right? So if we think it's cos, y is equal to -3 cos 3.01 bracket x minus, did we shift it anywhere? Cos normally starts at 1 and 0. Its amplitude brings it down to -3. Did we shift it horizontally? No. So x minus 0, or just x. But it's shifted, right? Because we would start at -3, so it would have shifted up 2 spots, right? So it's a +2. So this would be my cos equation for this thing. Could you make it a sine equation? Yeah, because cos and sine are basically the same thing, just shifted over, right? So we can make it a sine equation. Sine is the same period length, so our b is going to stay the same. Our a is either going to be +3 or -3, depending on where we're picking our starting point. So if I come back here and I pick our starting point, where do you want to pick our starting point? Right here? I think that's halfway, right? Yep. That's halfway. That's our starting point. We shifted it over. Do you guys know what this number is? 0.54. So we shift it horizontally. We shifted it horizontally 0.52, and then we went up, down. So our amplitude in sine is going to be a +3 because it went up instead of going down first, right? So we get y is equal to 3 sine 3.01 x. Now we shifted it forward, so we need to say minus 0.52 bracket. Where does sine normally start? 0. Have we shifted it vertically then? 2, 1, 2. Shifted it +2 up? I agree. And so that's our sine equation for that thing. Doesn't matter. What kind of answer did we have? Or what kind of questions did we have? Do you guys remember what questions I gave them yesterday? Then I give them questions 9, 10, 14, and I think it was 3 and 4 or 4 and 5. There was definitely a 14. Let's just do a 4 and a 5. Quit trying to give yourself more questions. No. Today's assignment.
Oh, I don't know when our today.
Because I gave it to the girls. Oh, I only gave them 3 questions today? Can I just see?
Yeah, I can text them and ask them.
You could text them and ask them if you want to.
I don't know if they'd remember. It's in their text.
Oh, they might. Oh, yeah, I gave them something different. I gave them, what did I give them? Question 2. Think I did questions 1 and 2 and 5. So this is our new assignment. That was our old assignment. I agree with you guys. 4, 5, 6, 9, 10, and 14 is our yesterday's assignment. Today's assignment, let's leave it as 1, 2, 5, and 6. If they text us back with a different solution and it's more, I don't know. Don't tell me. Questions 1 and 2 and 5 and 6 is what we're going to complete. Okay? If you only do A's and B's, that's fine. Just remember that if you want rewrites, you've got to complete more. And the more you practice is probably the better that you actually get at things.